What's up, everyone? Hope you guys have a great day. Good morning, everyone. Oh, morning anymore. The clock is 2 currently, and we're streaming right here and right now. Yeah, I've decided to take the face cam on today because it's probably going to be a bit of a boring stream if it's just this, because today we're doing driver shit. We're doing drivers for some fat drivers. Now, the fat file system is actually quite interesting. I actually have a paper here soon here. Let me just throw it on up here. So I have a paper here talking about the FAT 12, 16 and 32 file systems. All of them is nearly identical, not quite, but if we make a FAT 12 driver, then we also have a 16 driver, pretty much. Some legal ass shit and all that fucking. Can I please get down? Thank you. So yeah, we have some things that we need to get done. Okay, so a few things that needs to be set before we do anything. That has 5 regions. We have the boot sector, which is the first sector in any computer. We have the reserved region, which can be specified in the boot sector, where that is and how many there is. We have the FAT region. Then on FAT 16 and 12 we have the root directory, and then we have the file and directory data region, aka just the data region. Now I already have some everything set up to read a directory right here. Though what I do not have is, because if we really scroll down to how the here, so this is not that, here it is. It's normally a name. In fact, a directory name here is 11 bytes. That means they can be 11 characters. Now, if we have here that long directory entries, these things, ladies and gentlemen, for the first L directory name, we have 10 bytes, 10 characters. Then we have size bytes, yeah. Then we have 12, so 10, 12, that is 22. And then we have 4. That's 22, that's 26. Divide that by 2. I can't do that in my head. 26 divided by 2, that is 13 characters in total. Now, why do we divide by 6? Well, because this is in Unicode, pretty much. The long directory names are in Unicode, so when we can see it, if we find this one, if I fire this disk editor up, what the fuck is this? There's nodes. Open up virtual file disk. Here, open. It's already opened. Let me see. So here. Now if we navigate down to the root directory here, we can find, and we put a pin here. Oh, so here we have him. Need to remove my webcam real quick here. I don't know if this is too small or something like that. Maybe it actually is. I can't do too much. Anyways, but over here we have an entry here called the long entry. There's, for the first byte is the sequential sequence number, in this case A for the most part. Then we have the characters 1 through 5. In our case it is stage, STAGE. That takes up 2 bytes per character, you can see here. Then we have the attributes 0f, always. The type, don't know what that's used for. Checksum, you need to checksum. File name characters 6 through 11. In our case, 2 dot bin, and then the 0 character, and then just null right down. And then this one must be 0. 2 bytes here, that must be 0. And then the last 2 characters here. So that's how it's built. Okay. Now, much better. Oh. And now I can actually also see something. Now we already have it set up here as signed 16 bits. So words. Yeah, so name 1, 2, and 3. But what is interesting here is that then we also have so on top of this long name, a long entry thing here, we also have a shortened version of it. On top of that, which if we really quickly didn't do this, then we should technically have correct, but I'm not gonna do that because we already have this one, which is actually a union. I've just realized this things because I have in my bootloader stage 2 here we have a fat driver, right? And long names, block A, block B, reboot sector, fat detect, fat initialize, open entry, which we don't use, fat read, read entry close, get short name. So yeah, find file, and open file. So here we have some things. Long there, order, we do that. Okay, so yeah, we need to add support for long directory names. Wait. Let's do this. Let's add support for the long names, meaning that we'll first of all really quickly do this. Now, the next entry, if we have a long entry, the next entry is a shorter version of it. But now, 2 seconds, if I really go on the image root here, and have something like long file name, that's txt. How many characters is this? Long file name. That's 12. So if I do long file.txt, which is then like this. $12, 13. Didn't I also say 13? Yeah, okay, so we're gonna name it here. Now, if I really quickly build this, let's see what the fuck then happens. Now we're gonna here. I really think that we don't need to, if we also have 4 out of there and open it once again. Then we should be able to, if we open it here and open it here, go to offset root directory here. Say, oh fucking hell. Okay, so if we add a thing here, so 0, 1 to have here. Normally it would be like A here and A there, for example. A here. Was that the long one? Yeah, no matter, at least this is the long file name. So yeah, here we apparently have there. Then we have the first part of it. Doing some other shit here. So long F I L E N A there dot tx. Just barely. Just barely to greatness. Just barely to fucking greatness right there. Which is a little bit sad right now. Open that one. Navigate to there. So long right here, N, a dot here, T, Maybe we should also really quickly. I should also have it here. Always 0 and then txt here. And here we only have long f and then some kind of shenanigans here and then txt. I don't know what the fuck is happening here. But yeah, we have that, and we have an A here. So how do we actually like read this name? The primary goal is being let's find long directory entries. In order to meet the goals of locating of no wait, okay, it's a sequence. So what does this mean? Long directory order, I think that it is. The order of the entry in the sequence of long directory entries assessed with the short directory entry and at the end of the long directory. Okay. If marked with 0 hex 40 last long entry, this indicates that the entry is the last long directory entry in this set of there. Okay. A directory entry. Sequences of there. There's a first long entry. Okay. Yeah. Store of a long name within long directory entries. There we have that one. A name is created with the name quick dirty brown that fox. There. So first long entry THE space Q UICK space BRO. Oh, this means that the continuing, I think. Oh wait, what? We don't have like. So we only have BRO, is it then WN dot FOX? But this isn't this a short entry here? Or is this a long entry? No, this is a long entry. Wait, what? Okay. So what you're saying is that if I am going to like do something like this, let's just do this and close this one down. I'm gonna back up, go to root directory. E. Okay, so here we have a. Alright, let's see. Dot here. Oh. Okay, so we have the est dot t xt, and the rest is just ffs. So now so here we have the last part of it. So here we have the first part, long file name txt. Okay, so if let me just create a folder long names, and then have this one be long file name test. This is a really long name. Okay, and we make. Alright, so now I've put it into a file called long names, which should also be a long name thing. Here. Yeah, now here. Yeah. Long name here. I have to try to find. And then try to find. Here. Are we all ready to see this? Find. Oh. Okay. Let's really walk through what the heck is going on here. So 44, 3. So this is the last one. This is the last entry of the names. This is the third, the second, and the first. And then we actually have the entry. So now let's go down to the first. Let's read it. LONGFILENAN TET. Let's really quickly write that down. LONGFILENAN and then we'll go up here. TESTISAREA. Then we'll go up here. LLYLONGNAME dot txt. So the dot is here, the T is the first T is here, the X is here, and the T is here, and then we have a null here. Okay. That's actually fucking cool. I would never have thought of this. So we have first in sequence, second. Okay. I'm actually fucking surprised. And this just has a small part of it. That txt. And then of course all the rest of the information. Like this, the short sector, the short name down here has all the information of the file. Okay, that is actually fucking cool. So now, what you're telling me. Let's really quickly do one of these and just call this one long file. So we're going up into root, the root directory here, and we're really quick checking. So now, this one is the last one in the sequence. Last one in the sequence. Last one, last one, last one, last one. Of course, then zeros. So I guess if I find this character plus a 1, this probably means to 1, which then is this one up here. Let's see, this is a simple algorithm. The mnemonic tailgate generation algorithm. Yeah, here. Yeah. The tilde n string can range from tilde 1 to tilde 9999999. The number n is chosen so that it is the next number in the sequence. There's this letter there 1 and letter there 1. The auto-generated name of the name of this type would be the short name is only the basis name without any numeric tails. Okay, so if we have any numeric tails, aka tildes, we have a file name that is exceeding. We have a file name, for example, if we go down to here, we have a file name that says, hey, okay, we are exceeding the normal limits of this. Of course, we're ending it off with the .txt because we are. But we are saying, hey, this is beyond the normal limits of a short file name, so you'll have to look at the name elsewhere. AKA here at number 1, which then goes up to number 2, then up to number 3, and up to the end of 40, and of course into number 4. So if there's a 4 here, hex 4, 4x, I guess I can say, that means that we are probably at the end of it. I think that 40 means yeah, so 40x is the end of it. Last long entry, OR with n. Okay, so in code, now in code, we need a few things. Probably, we need a way to find a long name, concatenate there into a full string. Now, what was this block here? Yeah, so the order and the characters. Okay. So we need to first of all be able to find the characters. And order them. as we need. So yeah, let's first of all do this in the root directory here. So yeah, we are first of all going to check, yeah, fat element. So is there that entry? Now the entry here in our case is a long. Now, so we should probably cast it over to be a long one. The fat underscore long. So the long entry equals to. I wish I need to make it into a pointer. Entry here. Well, anyways, now if we do a long entry here, we're gonna check the order here. Now, if oh shit. Shit. Okay. So if the order is above the fat long file name last, so 40, invalid type conversion. So how the fuck is this an invalid type conversion? Do maybe have to like do so how do all right, yeah, I could also fucking just like take it from the root directory. That long entry. Actually, also this doesn't need to be. This does not need to be one of these. Oh, I'm fucking dumb. So now that we actually have it, we now need to actually make a block out of it. A long file name, a fat long file name block, one of these types here. The thing is the view actually good enough for you people out there wondering? Is this one? Well, then for me there's nothing. Nah, not quite. Let's really insert font. Yeah, a little bit, yeah, squishy. Squishy. Just want to be 100% safe. Was this one? Not that one. This one, right there. Right there. Okay, squishy. So we need to make it into one of these types. So get long file name block. So we need to get the fat long entry. Long entry. Use this as the result. Now with this, Alright, so now with this, oh, sorry. So now with this, like, we then need to now how the fuck can we do that? So split up into a few parts here that we need to then try to mush together, pretty much. How can we do that? How the hell can we do that? We could of course just do this. Do mem copies. This is the index G data. What the fuck is this G data here? General data, I guess, maybe? An F count, so why do we have to, oh, that's in the fat data. Two things, so we are, wait a minute, wait, what? Wait, so we are saying this, we're getting the index, we are doing the order, we are having the order. Then we are mem copying everything into there, and so we just have a big ass list of, okay. This is, how the fuck does that work? So if I really quickly two here, I do another one, let's call it number 3, and just place it down into root. Is there even space in the root for this? Oh yeah, a whole 3 fucking 6. A whole fucking 3 things for it. No, that's not enough. Huh? But actually then we can... What happens if I do it? Now I'm actually fucking curious. Like, does the root just expand? Now I am curious. What will happen when I do that? Right here. Okay, so there must be something here that has been lost. So you're there, you're there, you're there. Okay, so we have... What is it? We have stage 2. We have boot. We have su bin. We have the long file name folder. We have the long file name there, and we have the folder. Folder there. We're missing the text. The test. The txt. I do believe. Yeah, we don't fucking have the text. Test text. This one. We don't have that one. But why the fuck is it then? Oh, we found it, I think. Oh, here? Yeah, here. Okay, so yeah, here we also have fucking demo. It's maybe because the root directory has been now split into two. File extension there. First cluster high. I both must add 0, so nothing there. I actually don't know what the fuck is. What the fuck is it? Okay, let's try to calculate our way to it. Okay, so we need to figure out what sector it is, and then we have everything. So 3F3600 divided by there. Let's do it in decimal. We are in sector there. Which trick question? Question here, yeah, that's 2 bytes. Now, what is this result in here? So that is 1F9B. Okay. So where and holy heck do we have 2 seconds? I did not fucking do this probably right. Yeah, because it's not fucking text, it is in here. Find all. Or actually, I have maybe an idea on where the fuck it maybe is. After all the kernel and other type of shit. So yeah, if we place bookmark here, right, and we go to root, then we have folder here, which is this folder with demo.txt. Now let's go into there and check what the heck is there. So yeah, we have demo.txt. To be more specific, demo.txt has the words demo. Demo is here. What I think is going on is that we are waiting until we have passed through all the files in the root directory first of all. Then we're going into the directories one after another, and this is where the fun is, because first of all we are looking through stage 1 pasting it in as the first. Then we're going into boot. There's the directory, which then we're saying fuck that. There's a directory. That's a directory. This is file. So then we're taking that file, reading it, and putting it over. And this is file. Then we're going up again. And then seeing, hey, that's boot. Then we're going into the boot here. Finding the kernel. Right here. Passing through this. That's nothing, that's nothing. Here we have a file. We're taking it, pasting it in. Which is, I do believe, here maybe. Or maybe not. Actually, the kernel's here. Oh, this is stitch 2. But the kernel, where the fuck is the kernel then? I found the kernel. Do believe I maybe found the kernel. Let's go down to some more readable text maybe. Yeah, this is the kernel. Unhandled interrupts. All that is squishy. So that, yeah, this is the kernel. Then we have the kernel here. What do we then do? Yeah, maybe we do read this, paste it in. We read what's in here. In here, sorry. Paste it in. Then we go into the directory, look at what is in there. Okay, paste it in. That actually makes more sense. Because if we go a lot of shit down, kernel panic, a whole bunch of shit here. Oh, there's some alpha information here. Here we have the one and only long file name. Twice over. Actually, here we have a directory first of all. Just a directory. Actually, not even a directory. We have this one. Which came next. Then we have this. Then we had this long directory here. That then read it out. Here. But I don't know. I don't know. I don't know what the fuck is happening. Alright, but anyways, yeah, we need to check what happens here. Place point here. 44, and the same fucking shit here. Except for here we have a 4C, yeah. Could it maybe, no wait, because we don't have the same file name. What the fuck? Is the cause because order there. Let's throw all this in here. Actually, maybe the order that we're talking about here is just like nothing really there, and just a way to like have it. structures maybe. I don't actually fucking know. I don't actually fucking know anymore. How the fuck did I write this? Okay. I think we're gonna take that next. As next thing, let's just do a fat for now. Because we kinda have a fat function. Just not very good. Let's change that a little bit. Let's do a fat next cluster. Which the next cluster will get the current cluster wait, let's really quick get the current cluster. Wait, let's pass through instead of an index the current cluster down here, we'll pass through 0 because we don't have a cluster, and then we'll do here. Okay. Now let's do if now we have a fine thing called fat data here, where we can specify the fat type. It's 12, for example, 16, 32. Now let's make a fat index. Let's actually not initialize 0, because we're gonna initialize it here. Current cluster times 3 divided by 2. Fat 12, because it's fat 12. Then here. And for fat 32, it is times 4. Then make sure cache has the right number. Set a cache. So we have a gfat and then fat cache position. Now the cache here is this one. Now let's really quickly revert that a little bit back, because I had a model here that was maybe a little bit better. It's not there, but here. Scroll up. Boot sector. Here. There we have a cache, a fat cache, and a fat cache position. I'm really quick gonna close down the fucking thing here. Just like that. Okay, gotcha. So we have a cache position here, and then cache, and a fat cache. There's a fat of cache. Let's really quickly throw those two in. Now it's a little bit fucked, huh? Now in here we have a read fat, which we apparently also had the same idea of. That's always cool. Yeah, anyways, here you int 8 get the fat index sector, and then the fat index divided by the fat data dot the boot sector dot there. If that index sector is there with that data dot cache position, or the same thing but just that there plus the fat cache size, which in our case is 5. Then we'll do a fat read fat with the fat sector, fat index sector, and the size is self-explanatory and device, which that means we also need to get a device in here. Right here. So what this one pretty much just does, well, partition read sectors. Okay. And actually, let's rename this one to just fat read sectors, and that because then we can actually have it a little better. But instead of doing it like that, we can just say, yeah, do the fat cache, do it like, do this one, and read the number of fat cache sizes. Okay. Of course. And so we don't need to do that one anymore. We should also need to have that one. The def. Okay, and then we're gonna say the fat data dot fat cache equals to fat there. Now the fat index minus equals to fat data dot fat cache position times boot sector dot bytes per sector. Apparently enclosed. We're not gonna enclose it because it should be the next motherfucking thing. And then now we need to do some conditional things. There's some but 12 shenanigans that they do. Next cluster. And I always like to have braces around. There. There. Fat datas. Okay. Return next cluster. So now we have proved that we can actually. Now we can do this. Now does things still work? That's the next important question. Nope, it does not. 311. 311 here, which is the cache fat position. And the fat. That's not how you did it, Bjorn. This one we can just see. So. And run. Yes. No, right, yeah. Alright, ready? I guess it worked. Let's see here. Root directory is there. Fat sectors there. Fat there. The root directory is size sectors 2. Okay, yeah. So it actually. Oh, that's actually cool. All right. Let me just really quickly do some things here. So my things ain't so fucking cluttered all the fucking time. So yeah, the fat sector. So this one we don't need anymore. The FDS. And the root. And the fat sector. And the fat size. Why? Why are you doing that? Okay. Okay, so that should clean it a little bit more up at least. Yeah, that cleaned a little bit more up here. Of course, not quite as much, but still a little bit. And that's what counts. Let me see. Okay, yeah, so we have two devices from here. And then we have some data here about the fats. Why do I always try to like... Okay, so we don't need to know where the fuck the fats, where all that is. Okay. Moving up to here. So here we have long directory, I guess. Let me see. So yeah, here. So we need to pretty much copy it over to it. Let's really quickly do that. Let's just localize it for now. Which is not character. It's a U in 16. Name of and it's not even one of those. But it is 13 characters long, I think it was. I do believe it was 13 characters long. Now it was the destination. Now why is it 1, 2? I hope I can just do this. Yeah, we don't use... Now, how can we then like say that it is good enough? So if we say long entry and let's put this one as it, I guess. Oh, there was a lot of warnings. A lot of warnings. Long entries. TF. LF. Okay. Okay, let's really quickly. Yeah, what can we actually do? Hmm. Holy shit. What can we actually do? Hmm. Hmm. I just don't know what the fuck to do here. And I also think that this is going to be just a stream. I'll probably stream here later today. But right now, I'm just tired right now. Yeah. See ya.